Hey everyone, thanks for joining. My name is Marcus Burton. I'm a part of the office of the CTO here at Extreme Networks. I've been working on wireless for quite a long time, and then spending some time recently on cloud, data analytics, and thinking about 5G a little bit lately. So we're going to take this session to just introduce some of the 5G learnings that we've had lately, especially as it relates to enterprise wireless. And so this is going to be a little bit of a technical session. We're going to focus a little bit on the lexicon and terminology of 5G. And the way that I would sort of contextualize and frame up this session is this is an emerging technology. A lot of the use cases and applications for this technology for the enterprise are still emerging and will emerge over the next several years. So to pretend that we've got it all figured out, just like everyone else is pretending, I think would be a bit of a ruse. So really what we want to do in this session is just talk through the terminology, introduce it, and make sure everyone's comfortable so that we can sort of elevate the conversation that we all have in the industry going forward. So the first place we got to start is just to recognize that 5G is a big monster of technology, and that spans from radio and wireless technology all the way back into cloud and core and multi-access edge computing. And then it also spans into government and regulatory policy. It's become a big deal as it relates to sort of regulatory activity, even to geopolitical conflict. And so 5G sort of seems to be involved in a lot of different topics and conversations today. The main point here is I'm not going to be able to cover all this in just 25 or 30 minutes. But the thing that I've experienced as I've explored cellular technology starting back in like 2015 is every technology is somehow connected, and all of these things become like an entangled mess. And especially with 5G, you start reading about something like millimeter wave, and somehow you end up thinking about MEC or massive MIMO, or you start thinking about vehicle to everything connectivity, and you have this massive lexicon and acronym overload. And so my goal here is just to help sort of lay the foundations a little bit better for everyone so that when you read an article on A, you don't get tripped up on what B or C have to do with A. And so we're just going to try to give you some perspective on 5G. So, the first thing to recognize here is, there's this sort of challenge that's happening right now, which is pretty simple, really. It's that the appetite for data is growing very quickly. And operators and telcos and other types of service providers are wrestling with this challenge of delivering all of this capacity and infrastructure that's needed for this data consumption growth while also trying to reduce costs. And so it's an interesting challenge that they have to face. And there's a number of different ways within the 5G sort of landscape that are trying to address this. And one of the simplest ways is really just the business path forward for some of these businesses that have an investment in spectrum, where there's just massive amounts of investment in, on the order of billions of dollars. And then there's massive amounts of infrastructure investment as well, that these companies want to try to reuse to sell to enterprises. And so that's why we see these numbers related to private wireless growth. And so, these numbers that you're looking at right here come from one of the leading analysts in the industry, and their forecasts that are going out about 4 years from today. And so I think there's a really interesting point to make right up front in this conversation, which is that I don't look at private. So when I say private wireless, what I mean is private cellular in this case. I don't look at this as a competition with Wi-Fi. I can see a long-term future where they maybe compete a little bit more directly. But let's just call the next 5 years, these are very complementary technologies. And you even see it in these numbers, which is that Wi-Fi continues to grow, and this private cellular market that's going to kind of emerge out of nothing. It's not quite nothing today, but it's pretty close to nothing. This technology and this business that's going to emerge is really additive. And that's because these are new use cases that are expected to emerge, and that you're already starting to see the indicators of this when it comes to OT technologies, as well as IoT technologies, and maybe there's a very small amount of sort of Wi-Fi competition for some use cases that Wi-Fi is really not ideal for today. So these two things start to look like complementary technologies moving forward, and they actually grow together. They both serve a part in the way that enterprises think about wireless and connectivity going forward. So we can just kind of get that out of the way right up front. The other thing that I wanted to just kind of start with is this thing that just kind of frustrated me to no end, and it still kind of does, is all of this sort of like future imagery that comes with any conversation about 5G. And it just kind of nags me because I see AR, VR, and it's kind of like, yeah, everyone feels like they've got to say AR, VR when it comes to 5G. Realistically, this is not the thing that's driving 5G. And what I've started to learn and started to realize is we're using these images. I say we, like collectively as an entire wireless and connected industry, we're using these images as a sort of placeholder for an unknown future. And what I mean by that is simply that, this guy that's sitting in his connected autonomous driving car, and for whatever reason, he's got a Minority Report thing going on his screen. This is not what's going to happen in the future, but this is sort of an approximation of what might happen in the future, kind of. And so I think what we do is we latch onto this imagery that kind of represents a future of connected stuff and a future of applications and interactions and experiences that might happen in the enterprise and in our personal lives. And we're kind of trying to represent that in this kind of imagery. And so it frustrates me. And at the same time, I understand it. And I think the simple point is the killer app that 5G delivers is unknown to everyone. And if it was known today, it would be built already. It's unknown, and we know a lot of the applications that it will, that will connect via 5G, because a lot of them already do today. So these are not surprises, but the killer app that really drives 5G to be sort of this world-beating technology is unknown, and maybe it will never come to exist. But I think that's the point that is important here, is that like this future imagery doesn't quite mean what it seems to mean up front. So you can kind of discard this AR, VR stuff, at least in my opinion, and kind of just think of this as like, okay, there's a future that's unknown and 5G will help it along. And so will Wi-Fi, and so will BLE, and so will all of these other connectivity technologies that we use today. So the way that I kind of think about this market, and I don't know that other people would necessarily categorize it in these 4 blocks, but this is kind of a way that for me has helped to kind of segment it up, which is thinking about these market approaches. Like there's public cellular access, which is kind of the cellular that we all know because we have mobile phone subscriptions and we connect to wireless technology via a tower, and we experience mobile broadband this way. Then there's a private version of this, and this could be sort of a standalone isolated network that an enterprise owns and operates on their own premises, or this could be bought and operated as, just call it a slice of a public network, which just means you're getting some sort of guaranteed SLA from that public service that the enterprise would consume for its own purposes. I think most of these are going to actually be on-prem, enterprise controlled and owned, these private deployments. And then there's IoT, which is really kind of more about what's connecting to the network than it is where it's being deployed. But there's kind of a public and a private version of this, and different types of things that need to connect to this IoT version of 5G. Then there's fixed wireless access. You can call this wireless WAN, which is basically just using 5G and other cellular technologies, including LTE, to connect homes, small businesses, medium businesses, as a primary broadband option, or as even a backup or a tertiary option for connectivity. So kind of 3 broad market approaches. And those 3 broad market approaches are kind of one view of the picture. Another view of the picture is these 5G usage scenarios. There's 3, and you'll hear these terms. This is where we kind of get into the lexicon speak of 5G, which is enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. You all can read this on the slides, but basically it just means mobile broadband gets better with more capacity and higher speed. And then you have like this kind of class of low latency, reliable applications that need to be delivered in a different way. And then you have this IoT sort of MMTC approach, where we're trying to solve this, this sort of increase in connected things. So 3 different usage scenarios, and each of these usage scenarios map to different requirements. So when the 3GPP groups were getting together at first and kind of saying, hey, what should we do? What does 5G need to solve? These were the 3 sort of categories of problems or uses that needed to be solved. And so it drove these different sort of requirements that are kind of shown in this spider chart. And this is kind of a common way to present the requirements that drove these 3 usage scenarios. So you'll see with mobile broadband, it's kind of like the primary connectivity stuff, like faster data rates, better capacity, more spectrum efficiency, kind of the standard stuff. For ultra reliable low latency, it's really mostly driven by latency, but also by mobility. And then the massive machine type communication for IoT is really just all about increasing density of devices that are going to be connecting to the network. And so you see these kind of three legs of the spider chart, and they're not necessarily, in some cases, they're minorly overlapping, but for the most part, they don't overlap. And this is important because each of these three usage scenarios requires a different kind of network. It requires different things from the network. And so the way the network is built to solve these three sort of broad classes of problems or situations will be different. And so this is important for enterprises to recognize that, like, what you do for faster mobile broadband is not necessarily the same thing you do to connect a robot in a factory. And so we'll talk about that a little bit more in just a minute, from what that looks like from an architectural perspective. Before we get there, I just want to kind of, again, level set on components of a cellular system. So as we talk through these terms, you kind of know how it fits. So there's the mobile device or mobile equipment, which doesn't have to be a mobile phone. It could be any SIM-enabled connectivity device. And then there's the SIM, or increasingly an embedded SIM, which is a combination of hardware and software, which is basically your credential by which you access the network and are authenticated and given a policy and permission. There's the RAN, which is the radio access network, which is basically the combination of antennas, radio units, baseband processing, basically all the stuff that makes cellular a wireless technology. Then there's the core, which is a combination of sort of data traffic handling, or the user plane function, and the control plane function, which is kind of all about authentication, session management, mobility, all of these sort of orchestration pieces that enable the wireless network to do what the wireless network does. The OSS and BSS is basically your management and operational suite that integrates with backend systems and is used for troubleshooting, diagnostics, reporting, all of that good stuff. And then I just kind of have the internet here because most apps today in most situations are delivered via the internet, via a cloud service provider somewhere. And then kind of in the middle, you have this dotted line, which just represents transport. There's kind of front haul, which is like RF connectivity between the antenna and the radio. There's mid haul and back haul, which connect, the tower to a regional data center or a central data center, where different functions are kind of aggregated or distributed across the network. So that's what transport is all about. And there's a number of changes that are happening within the 5G system across all of these different layers. I've noted just some of them down across here at the bottom. I talked about eSIM already. The RAN is going through a really significant shift from more of a hardware-centric RAN to a virtual RAN, and then OpenRAN to open up the ecosystem. There's new spectrum coming available, and we'll talk about that in a minute. There's a cloud-native core side, which is basically moving from kind of a virtualized core services and service chaining, with VNFs, into something that's more of like a containerized, orchestrated approach that's very similar to the way that software systems are designed in the cloud for the last 5 or 6 years. And then there's MEC, multi-access edge computing, which is basically the way that we deliver applications, where the computing resides, and kind of the whole delivery mechanism for edge computing. So lots happening here. So all this to sort of bridge back to those usage scenarios to say the architecture that delivers those usage scenarios is also different for each one. So if you think about kind of the mobile broadband use case, this kind of maps to the way that primarily 3G and LTE architectures have looked, which is that you have kind of this distributed RAN wherever you need a radio, and then you have kind of some form of centralized RAN at local data centers. The core could be at a centralized data center, or kind of some of that functionality could be split between two places. You have the low latency use case, where basically the entire goal is move everything as close to the user as possible. So, if you want things to be low latency and you want it to be ultra reliable, take out every unnecessary hop and link and intermediary between the user or the device and the application itself, and basically make that path as efficient as possible. So move everything to the user. And then IoT basically does the exact opposite thing, which is we just need to connect lots and lots and lots of things. They don't even really need to move a lot of data. We just need to have very scalable systems that enable all these things to connect. And so kind of move all that into centralized lower cost cloud data centers. And so, you might see these different architectures deployed, and the type of problem that you have as an enterprise to solve as you kind of work out your use cases that might be sort of friendly to private cellular, private wireless, you'll start to kind of think about these architectures and how they fit into solving the use case that you have. But just recognize that like 5G isn't just one thing for one set of uses. It's this variety of things to solve a variety of problems, and they're not necessarily completely harmonized. So moving from sort of the architecture and the core side of this into the RF and wireless side, just want to talk a little bit about spectrum and bandwidth, because ultimately everything in cellular and private wireless comes back to this. So there's kind of an introduction in 5G of this high band spectrum. And so just to kind of contextualize what that means, there's low band, mid band, and high band, where low band is basically anything that's below 1 gigahertz from a wireless bandwidth and frequency perspective. Mid band is what's between 1 gigahertz and 6 gigahertz, and then high band is basically 6 gigahertz and up. And so you kind of see this image here as just a visual illustration to show kind of the RF characteristics of each of these bands. And these are not like hard and fast like band demarcations, because it's like the high end of mid band, let's say 5 gigahertz, and the low end of high band is 7 gigahertz, like these are basically the same thing. But just think of them as kind of general sort of RF characteristics that map to these bands, where low band is really good for coverage and for long range, because the RF properties of these low frequencies with long wavelengths are really good at traveling over distance. They're not impacted as much by obstacles, by buildings, by foliage, all of that kind of stuff. So great for range. There's just not a lot of bandwidth to work with here. So it's not as ideal for sort of high bandwidth, high capacity sorts of deployments and requirements. But when you need to cover a large space, like a rural environment with fewer users, it's great. Mid-band is kind of like this Goldilocks principle. It's like pretty good at coverage and pretty good at capacity, not phenomenal at either, but not poor at either. It's kind of somewhere in the middle. And mid-band really does most of the heavy lifting and is kind of seen as like premier spectrum for 5G deployments and LTE as well. And so low band and mid-band have been, what we've used for cellular connectivity, going all the way back. High band is new to cellular in 5G, and primarily the focus here is kind of on around like millimeter wave. So, it's called millimeter wave because at like 30 gigahertz and above, the wavelength of that frequency is measured in millimeters. So, so high band in this spectrum basically has the exact opposite characteristics as low band, which is because of that RF characteristic of the millimeter wave, the coverage aspect of this spectrum is really poor. Meaning, if you put a radio on a street corner, you might get access halfway down the block, but not much further. And you're probably not going to get coverage or service inside that same building. So, it's kind of eaten alive by obstacles, foliage, around the corner of a building doesn't work as well. But what's great about it is there's just massive bandwidth in this spectrum. And so when you start to aggregate channels and you have lots and lots of subcarriers that can carry data, you can actually move loads and loads of data, but you're range constrained. And so you just kind of have to look at this as three different pieces of building block that you can use to build a network, and they're each optimized for different purposes. So no one is necessarily better than the other unless you have a specific use case to solve. Then there might be a better fit for one or the other. And just to give you kind of a little bit more context or a picture to kind of map with that, this is just kind of a coverage map, just kind of randomly of a provider in the US, kind of looking at like 5G coverage across the US. And what you see here is all of these little circles are basically hotspots of millimeter wave coverage. So when you think about, you solve most broadband with low band and mid band, sort of frequency ranges, what we just discussed. And then you solve the high density, high capacity, really high user density areas with millimeter wave. So kind of looking at this and bringing it home, I think for me, a picture paints 1,000 words here, where when you look at sort of very zoomed in, this is the city that's closest to where I live. I kind of live in a rural area because I'm that kind of guy. But you see like this red coverage is like the macro coverage of 5G with mid-band. And then you see these darker red lines that contour almost perfectly to roads. There's a reason for that. These are the millimeter wave coverage areas, and you can see that there's maybe like some parks where it's more open and you get a little bit better coverage in those parks. But for the most part, this follows the contours of roads because of the RF properties and characteristics of millimeter wave. So this is, again, not to say that millimeter wave is bad, just to recognize that low band, mid band, and high band are each useful for solving different types of problems, whether it's a pure coverage play or something between coverage and capacity, or just a pure capacity play, which is what millimeter wave is good for. So one more sort of way to think about what's evolving and happening within the RAN is to kind of look at these terminologies, which is VRAN and OpenRAN. So let me just walk you through it a little bit here. So the LTE approach, and prior to that, was really to have proprietary hardware and software that makes up the radio access network, and it's kind of sold as a proprietary end-to-end solution. It's all kind of integrated together. There's specialized hardware that runs the baseband. There's specialized radios that run the radio aspect, and the kind of the lower just consider it like closer to RF side of RF processing. And then as you move up the protocol stack, that's where the baseband is involved in that. So this is kind of the standard approach. So what's happening with 4G and 5G with VirtualRAN is basically the virtualization of this, hardware-centric approach, or historically hardware-centric approach to RAN delivery. So I'm hearing Mark Andreessen a little bit in the back of my head, which is that software is eating the world. And so if you can deliver via software, something that has traditionally been a hardware-focused platform, generally there's economic benefits to doing that. There's flexibility benefits to doing that from a management perspective. And so that's what you see happening and accelerating. Remember back to the early conversation, which is that data demand is increasing while operators are looking for ways to reduce costs. And so this is one of those ways. So basically, if you can run that same RAN functionality that's always been proprietary hardware as software, and then run it on commercial off-the-shelf hardware, and you get some economies of scale in terms of the hardware you run it on, as well as the tooling that you use to operate it. Hopefully there's a little bit of increasing price pressure that happens here because you don't need that proprietary specialized hardware. So it ends up being a good thing for the cost model. And then OpenRAN kind of takes that a little bit further, which is basically a way to define a RAN that has more interoperable and open interfacing. In other words, if you take the entire RAN as kind of one encapsulated set of functionality, and you carve it up and you kind of define these demarcations for a radio unit and a distributed unit and a control unit. So basically saying like different stacks of the processing of the RAN. The whole idea here is that 5G has defined these interfaces between these segments of the RAN so that it's a little bit more modular, so that different parts of the RAN can be delivered as interoperable parts. So if you say we want to buy a radio unit from one vendor and a distributed unit for another vendor and a control unit from another vendor, and kind of piece and part them together and go for more of a best of breed approach, by breaking the RAN up like this, you enable competition and you enable a little bit more innovation at these different segments of the RAN and its delivery. So there's another aspect of this as well, which I want to just touch on briefly. I know I can't speak, this is its own conversation, but the markets and the vertical sort of interest in applications of private cellular, I kind of put these in somewhat of a random order, other than with the exception of manufacturing on the top, which is clearly sort of the primary first mover when it comes to adoption of private cellular, because there are more connected and mobile things in manufacturing environments that are connected to this entire drive for increasing IoT, OT, and even IT automation that is embedded into the manufacturing process. And then you have all of these other interests. Each one of these kind of has different drivers. So, education is really motivated right now to kind of bridge the digital divide, as people say, and connect communities that are otherwise unconnected with this, distributed learning. Healthcare has applications, and then you have kind of these pop-up COVID environments where this kind of connectivity could be useful. Transportation networks, whether it's a seaport or, other types of transportation where they want to connect things in a wider area zone where Wi-Fi is just a little bit suboptimal. Connected utility. So all of these, different verticals and markets have different applications. And there's kind of this like interesting intersection that happens with verticals and the way that this happens and applies across, sort of the geography of the world. And so that's the right side of this picture, which is kind of getting a sense of how spectrum is available for different enterprises to be used. So this coloration might be a little bit confusing. Let me just kind of clarify real fast. The green ones are where there's only a license model. And that's to say, every country has a license model to cellular. So, you take some spectrum and you auction it off to operators. The operators build 5G on licensed exclusive use model. So they all have that. But as you move towards this limited shared and then shared models, basically what you're doing is enabling enterprises to adopt this technology in a way that's more flexible, more extensible, and usually lower cost as well. So you start to see some limited shared adoption of small blocks of spectrum, 10, 15, 20 megahertz in parts of Europe and then Japan. You see the shared model very strongly in the US with CBRS as well as the UK, where they've got several different blocks of spectrum open for kind of a lightly licensed use, which makes it accessible to enterprises. There's Germany, France, the Netherlands, Sweden, all have a shared model in Europe, which is basically making this a more accessible approach for enterprises. So you kind of see these two things aligned together, where you've got to think about the vertical within a country with a different, with a sort of spectrum access model that enables them to actually deploy this technology. The other option is just to work with license holders, which just, it creates a certain kind of complexity, both in terms of business and technology. And for some use cases, that works just fine. So we had a limited bit of time, but I want to just kind of cover those basics and make sure we're on the same page. I have a few takeaways, which are just some statements. Cellular wireless is big business, okay? There's incumbent providers that have investment costs in spectrum and infrastructure. They want to use it and they want to sell it to enterprises. And so that's not a bad thing. It's an option, but it's not the only option. Cellular wireless is a tool in the wireless tool belt. And I think of this especially through the lens of Wi-Fi, LoRa, BLE, other types of connectivity tools. Cellular wireless is not going to take away Wi-Fi. That's just not going to happen. It's a tool that solves some problems. And if the use case is right for it, use it. If it's not right for it, Wi-Fi and other technologies are still great in a lot of ways. Cellular wireless has a long adoption life cycle. So if you think back to LTE, way back in 2008 and 9 were the first deployments, and it's still being evolved. So you see LTE Advanced Plus being deployed still. So 12 years later, it's still evolving. So we've got to look at this through the lens of very early in the 5G life cycle. We'll see a lot of traction over the course of the next decade. And everyone says it's a sprint. It's not. It's a marathon, and it's going to take a lot of time. So now's a good time to be thinking about it. And then the other point is just that this technology has a role in the infinite enterprise. And by that, I just mean enterprises need to connect users and devices on campus, off campus, in homes, in public settings. And there's different ways that you can apply private wireless or cellular wireless in a private environment to solve different types of infinite enterprise challenges that are coming up. And really just when I think about it for enterprises, now is just the right time to be thinking about and learning about this technology because it's emerging. You're in the right side of the curve to be learning about it. So that's 5G for the enterprise. Again, my name is Marcus Burton. Thanks so much for joining. I really hope this session is useful and just gives some context as you explore 5G for your enterprise and what problems you can solve with it. Thanks a lot.